Hey everybody, this is Alex Merced, and welcome to another episode of Select Star from Data Lake. Okay, where we talk about data lake stuff, and what we're talking about today is specifically Nessie. Okay, I've talked about Nessie before, probably like a few episodes back. Um, and again, Nessie is a open source catalog technology, and I've talked about before, where it brings you sort of versioning, so you can create branches of your catalog, you can roll back your catalog, you can tag your catalog, which enables things like isolating your ETL. That allows you to have really easy disaster recovery. Allows you to create reproducible states of your catalog. Allows you to create sort of zero copy experimental environments. All sorts of really good stuff. But how does it work? Like, how does it able to kind of maintain that kind of level of isolation and do that in a really lightweight way? Well, the way Nessie works, okay, is that essentially all the catalog is a list of namespaces. Okay, in the vernacular of Nessie, they're referred to as keys. Okay, so a key is really just like an array of strings. Okay, so imagine you have a table called db.table1. Okay, in the metadata, really, it's holding an array of strings of db as the first string and table1 as the second string. And that key then has metadata sort of attached to it. Now, built into sort of like Nessie's validation is that basically it can't just be any random metadata. It has to be sort of in certain categories that Nessie supports. So again, if you want to support other types of metadata, you would have to then do a pull request into the Nessie project or customize a fork. But because basically these things are validated. But essentially, what happens is that, for example, there's like the list of things that you can currently save as sort of a Nessie key, or as the metadata for Nessie key is an Apache Iceberg table. Okay, so that's one type, and basically what it does, basically what all is really attached in that is going to be the data about the commit, like when it happened and all that kind of stuff, along with the metadata location. That's going to be sort of the key prize in the Apache Iceberg table one, because it's essentially what any engine connecting to a catalog for Apache Iceberg is looking for. They're looking for, hey, where's that location of the most current state of the table? And that's the location of the metadata.json. Okay, then there's also a namespace category, which you have to create namespaces. So, like, for example, if I want to do db.table1, I have to create a namespace db as its own key, and then I can create db.table1. Okay, so like Nessie in its current latest version has like more stricter validations of like namespaces. Like namespaces actually have to be sort of created. Tools like if you're using Dremio that interacts with like Nessie, it'll create those namespaces for you when you create folders in your Nessie catalog, because it's aware of that requirement. But let's say you're in Spark and you want to create like db.table1, or like let's say you want to say nessie.db.table1, you would first create the namespace and then you would create table1 in that namespace. But so those namespaces have their own metadata, which is really just the name of the namespace. There is Iceberg views. Okay, that's another category you can save, and that metadata really just saves like the actual SQL query that's attached to that view, which doesn't have to be the specific syntax of any particular engine. But theoretically, you want to keep it as close to ANSI SQL as possible, so that way it's portable. Because the idea is then you can actually have portable views. So any Iceberg views you make in Dremio per se would then be available to you in other engines. And again, long as the exact SQL syntax is supported, basically other engines can then load up the same exact view. Okay, so you're creating portability of Iceberg views and Iceberg tables. There's also a Delta Lake where it holds certain metadata for identifying a Delta Lake table. RAT support isn't fully active just because there is changes that have to be made to the Delta Lake format. There was a pull request to make such changes that never got merged in, so that is currently to be revisited at some point. But theoretically, there's nothing sort of preventing other types of metadata about your data lake to be stored in Nessie. Again, it's just kind of adding those sort of types to it, because that's what all Nessie is doing. It's just saying, okay, here are all the keys that I'm currently tracking. This is the metadata attached to those keys. And then anytime one of those keys gets changed, or a key gets added, or a key gets removed, that turns into a commit. and you create like a new snapshot of that list. Okay, so essentially like Git, you have all these snapshots of all these keys and their metadata. And then when you create a branch, you're just creating a different branch of commits that's capturing all those sort of changes to the keys and the metadata. But the idea is that since you're not tracking every individual file, so unlike a system like Lakehouses, which is capturing sort of the state of your file system and changes to your file system, you're tracking as many different individual objects. So one commit isn't adding like 50 individual files, you're adding a single key. Because again, the link would be to like your Iceberg metadata, and your Iceberg metadata would be where all the individual files are tracked. But there'd be a new metadata.json file. But the thing is, but on the other side, like Iceberg table versioning is also pretty lightweight, but it's only tracking one table at a time. So if I want to tag a particular state of my catalog, I'd have to tag each table individually, which can be cumbersome. So this is where like an abstraction like Nessie becomes really useful, because when you're working with dozens, if not hundreds of tables, tagging them or rolling them back individually may not necessarily be the ideal. So having this catalog level abstraction works really well. So hopefully you guys enjoy this. Kind of really, hopefully this helps you better understand how Nessie works. And again, the way all those changes get made is through a REST API. So there's a V1 and V2 version of the Nessie REST API, and essentially, you know, there's API endpoints that allow you to grab the tree of commits that allow you to add new events. Okay, so events can be either a commit, so you're like either adding or changing a key. There can be merges, which are where you take a commit from a different branch and bring it over to a different to the head of another branch. What's the third one? There's a third category of kind of change you can make, but again, there's all these different changes, and all of them have a pretty well-defined schema as far as what these objects, the data is structured at. So essentially, all it really is you're just sending all these REST API calls, sending over the right metadata about these commits, and then these commits get updated, and then different engines can now basically monitor the changes to your data lake or your data lake house. But again, it's not limited to just Apache Iceberg tables. The way it's structured really expands it to where it can really track anything as long as it has like the right validations built into it. So, you know, you can imagine that it can track all table formats, or even like track directories where a Parquet table maybe exists in the future. Like, there's a lot of theoretical possibilities of what's possible. Okay, my name is Alex Merced. You're listening to another episode of Select Star from Data Lake. Also, make sure to check out new content over there at the Dremio blog at dremio.com/blog. We have a lot of new articles, especially about like using Flink with Iceberg, types of data validations, use cases for Dremio. Lots of great new content over there. Also on the dremio.com/YouTube channel, where lots of videos have been added, including a whole new hands-on intro to Apache Iceberg video work through that you can work through. So I'll see you all later. Have a great day and enjoy.